As we've discussed in a prior movie, an array is similar to a list. So how is it different than a list box or combo boxes? List boxes and combo boxes are controls that actually exist on the form. Data is loaded into those controls through the items collection property editor or via code to import data from a data file. Users of the program have interaction with the list box or combo box. The data associated with an array is protected from user interaction. That is, the data with an array is in memory and cannot be directly accessed by the user. Array data is generally more static than data associated with list or combo boxes. Keep in mind that arrays exist in memory, not on the form. Data that is stored in an array can be retrieved for later processing, such as averaging a group of numbers after they've been entered, or some other calculations. List boxes and combo boxes are natural partners for arrays for applications. This is true because they share a commonality of subscripts. Subscripts are zero-based in both arrays and list and combo boxes, and therefore can be linked through code and table lookups. The selected index property of a list box can be used as a subscript for the corresponding array. I will now launch Visual Basic and provide a demonstration of how arrays and list and combo boxes can be used with each other. In this sample program, I have a list box which simply contains a list of names. If I open up the Properties window and look in the Items Collection property, you'll see the names are listed. And I also have a button which is going to serve as our point of interaction for the user. What you can't see as the user is that there also is an array that has been defined in memory. If I open up the code window, you will see that there is a statement, a dim statement, that is defining an array called name array, which has the contents of the same names that are in the list box. Now these names would not have to be the same, but for the purpose of this demonstration, I'm making them purposely the same. When the project is executed, the contents of this array is loaded into memory. Again, the user does not see this. All they can see is what's in the list box. When I click on the button, two message boxes will appear. One will simply tell me what the selected index is of the item which I have now selected in the demo list box. The second message box is going to display a message that says the corresponding name in the array is, and if you'll notice where the data will be coming from, is coming from name array. Name array is the name of my array that exists in memory. The subscript for name array is actually the selected index of the demo list box. So the result should be, since I have both names in the list box and the array as being identical, that once I am provided the selected index, which will simply be a number, then it will tell me what name is in the array with that number. Let's run the program to see this in action. At runtime, you now see the list of items, and I'll choose Tom, which is the third item in the list. But you'll recall that subscripts are zero-based, so Tom actually has a subscript of 2. Bill being 0, Sue 1, and Tom 2. So when I click on Find Subscript, the first message box I see tells me that the selected index is indeed 2, which is referencing the location of Tom in the list box. When I click OK, the second message box is telling me that the corresponding name in the array is Tom. Once again, this is using the number 2, which happens to correspond to Tom in the array itself. So this simply is illustrating the fact that you can use the same subscript in two different controls, one being the control being the list box and one being the array that exists in memory. We will look at other examples and other demonstrations of how arrays can be used to manipulate data and the use of subscripts.